Hey, what's up? Jason here. Have you ever been working on a game that seemed like it was working great, everything was running fine in the editor, everything was good on your computer, but then you went to deploy it to a device and suddenly it fell apart, or maybe you gave it to somebody else and they tried to run it and the performance just wasn't there. It fell apart and broke and wasn't playable. If so, then this video might be perfect for you because that's the scenario that one of my students ran into. She was building a game, got it all going, everything seems good, plays fine in the editor, plays fine on a laptop, but you go out to an iPad and suddenly, well, performance just isn't up to par and doesn't work. So I'm going to give you some tips today on how you can avoid that, some really quick, simple code tips that will resolve most of these problems, and my number one tip that'll solve just about all of them. Now, before we get going, if you have any good game performance tips that you can share, please drop them in a comment below. They're really helpful, and everybody reading them, I'm sure will get some use out of them. Also, don't forget to like and subscribe. And if you're curious about being a student of mine, just check out the link below. You can see my new course that just opened up. All right, let's get started with the most important tip, and that is to learn to use the profiler. Before we get into debugging code issues and fixing minor code things, you need to understand how to use the profiler, or that it's there. It will save you a ton of time. In fact, it could save you years of just pain and frustration. It's one of the few things that I wish I'd learned about earlier. So here I've got a project open. This is from my new Angry Birds tutorial that'll be coming out for Unity 2020. And it's just a bird that I can drag around. Nice simple game, and I can launch birds over there. It runs fine, but there might be some performance issues when I deploy it out to a device. In fact, I know there will be because I intentionally put them in. Now I'm going to open up the profiler and show you how I would find those issues if I didn't put them in intentionally. So what we do is go to Window and then go to Analysis and Profiler. By the way, there's a new standalone profiler that's really cool. Pops out a second window that's not completely tied to this Unity instance so that we can profile without getting the downside of the performance impact of the actual editor. So you might want to check that out if you're not new to the profiler. Let's go into the actual profiler window though. So go to Analysis and Profiler, or Control-7 to open up the window. This should pop up a window like this. It might be off screen. If it is, just grab it and drag it over here. What I usually do is take the profiler and dock it down here by the project and console. This makes it a little bit small so I can't see everything, so I just drag it up a bit. Now there are a bunch of different areas in here that we can scroll through. There's the CPU usage, which is where we're going to be focused today. There's rendering, memory usage, audio stuff, video physics, 2D physics, networking, UI details, global illumination, all kinds of different stuff you can profile. Again, we're going to focus on the code stuff today. It's the simplest and easiest to fix, and it's also the most common problem that just about all of us will face. So here you can see just a bunch of bars going by. If I stop playing, those bars stop playing. It's just showing me the profiling data for every single frame of the game. So imagine we run at 60 frames a second. This is going to show me 60 frames worth of data every second. Here you can actually see the frame counts that it's done. So if I just click anywhere, what will happen is the game will pause and it'll show me the data about the specific frame that I clicked on. So I clicked on this frame right here, which has a frame number 26121, and it's going to show me the information about that frame on this little bar chart, or I guess it's an area chart, but also down here in this overview. If you don't see the overview, you might be in timeline view. Switch over to hierarchy view. Timeline view is useful if you're doing a lot of multi-threading stuff. If you're not, hierarchy view tends to be a lot easier to use. So I would recommend starting with hierarchy view until you get really familiar with it, then maybe looking at the timeline view. So here it says we've got an editor loop and a player loop. I'm going to expand out the player loop. There's something to note here. I have the deep profile button checked. If you don't check this, what you'll see is that you'll get some of this data, but as I expand it out, you won't see all of the script specific details. You have to check deep profile before you play to actually get the script specific details of your script. So let me show you what that looks like. Here we've got our player loop, and you can see here it says update run script behavior update. And if I scroll over to the right, or just move my mouse over to the right, you'll see that the total percentage of the time was 16%. So that means that 16% of our game's time, or our CPU usage, was spent just running our script's updates. So whatever it was in there took 16% of the time. That may be a big deal. It might not be a big deal because it might just be that our game isn't doing anything else and the rest of the time it's just sitting there waiting. So don't always worry about the percents. You want to worry about the percentages when your frame rates are dropping. Then it makes it really easy to tell which thing is the highest. The thing that I want to look at though is the time in milliseconds. Right here you can see it's at 0.5. I also want to look at the GC alloc because this is another big one. Garbage collection allocation is a big problem, and it will cause issues with our game where we'll get stutters or freezes through the game, especially if we're building out to a mobile device. So let's expand it out. And here you see it says behavior update. I'll expand one more time and we can get to the actual code that's offending. So it says our monster update has an issue, or our monster update not necessarily has an issue, but is the top thing in our profiler. It's the most expensive or slowest thing, and it's the most expensive by a lot. If we look at the time in milliseconds, it's half a millisecond. Again, tiny because we're running on a really, really fast device. We run on a slow device, this is going to be much bigger. But if you compare that to everything else here, which is like 0.05, 0.02, 0.02, and 0.15, it's by far the biggest thing. Now your numbers are definitely going to be higher if you're in a real game, by the way. Let's expand this out though, and we can see a little bit more. And look at that. Debug.log. This is probably the number one thing that ends up killing performance for people, is that they start writing out a bunch of logs and they don't realize they're also writing them out to devices. I'm going to show you how to fix that in just a minute in the next tip. Now, I don't want to go too deep into the profiler. I have a whole video on that. You can check it out if you're curious. But I do want to show this little spike here, these little bump areas. If I scroll over or just kind of click and drag over, you can see the numbers adjusting for the frame. And I can get to these big areas where there's a peak. And this is usually what you want to look at. You want to look at a couple frames along here and then find these big peaks and see what's happening in these peaks. And if we expand out our behavior, you'll see that we're actually getting this collection, this gc.collect. That's what these big spikes right here of this orange are. And that is the thing that's going to cause the big freeze or frame loss or just kind of a pause on a slower or older device, or especially on a mobile device. And that kind of leads us into some code for our next issue, which was that debug log. How do you stop debug logs from spamming on a device and killing performance? There's actually a really easy trick that you can use. I'm going to expand out this awaken my monster and show you what it looks like. We can actually call debug.unitylogger.log enabled equals true to turn it on or false to turn it off. And I'm using the if defines, or the pound or hashtag if defines, I call them pound defines, for if it's in the Unity editor or if it's not in the Unity editor. What this is going to do is compile this code only if we're building for an editor build. So if we're basically hitting play in the editor, if we're doing a release build or even a debug build that's not a release build, but we just did a development build, this will still run because we won't be in the editor and it will turn off all of our logging. So this is just an easy way to disable all logs on all of our builds. Pretty cool trick, right? All right, let's go on to the next one. The next tip will take us back to the profiler, but first we're going to look at the code, and that's right here in our update. This is the code that was actually running slow when I looked at it in the profiler initially. And here we're trying to find the nearest other monster. These are just monsters in our game. So you see these little bad guys right there. And we just want to find the nearest one, and he's just spamming out that he's closest to that one. Imagine we want to do some kind of friendship or allyship or healing or something between them. Right now we're just logging it out. So this code right here seems relatively simple and straightforward if you're very familiar with LINQ. If you're not familiar with LINQ, it might look terrifying. Don't worry, I'll explain it real quick and then I'll explain why this might be an issue. So here we're finding all of the objects of type monster. So we get back all of our monsters, and this is just going to give us an array of monsters or a big collection of them. Then we're going to filter them using the where statement. This only works because we have using system.link up there. If we don't have that, our where won't work. It won't show up as an autocomplete. We'll have a compile error. It might recommend that we add using system.link. So what is this where statement doing? Well, it's saying, hey, for every object in this list, so for everything in this set of monsters, refer to each one as T for a little comparison right here. So we'll say for every one of them, if it's not equal to this monster, so the actual monster that's running this update, then it's filtered into our list. So where means, hey, only include the ones that match this case. So the ones that are not equal to this. Then we're going to sort them with the order by. And the order by does the same. It'll use this T variable for every instance of them. By the way, I can change this. It doesn't have to be T. It could be M for monster, or I could even use like a full variable name like monster. And they can be different in between these, or they can be the same. The scope of this variable right here is only in the context of this one statement, this order by. So this is filtering them and then ordering them and then finding the first one, or default. Default for monster is null because it's a class, and that means it's nullable by default. So it's going to find us the nearest monster in our update. Seems pretty simple. It's actually really, really fast code to run. If we go into the profiler and just take a peek at it, go back to the profiler, and I expand it out, you'll see that our first or default was really fast, 0.1 milliseconds. Our where statement right here is 0. Our order by is 0. So you might think, hey, this is all great. It's nice and fast. It's easy to understand if you're familiar with LINQ, and it just kind of works. There's an issue though. This GC alloc right here, we're allocating a tiny amount of garbage, a couple hundred bytes every frame, but it adds up. Right now, without the log, I don't know exactly what we're at, but it's still a good amount of, what are we? I guess 1.3 kilobytes of allocation, and that adds up because it's every frame. So if we do that 100 times a second, you know, it's going to build up really, really quick, and we start to hit these issues. So with LINQ statements, don't use them in an update. Don't use them in cases where they're going to be run regularly. It's fine for one-offs. It's fine for an update, or not an update, an awake, a start, or just a one-time method that needs to run and generate some garbage is fine. But don't do it in something that's running every frame. Avoid LINQ statements in updates, essentially, and in fixed updates, or in anything that's just constantly running. Minimize them, and again, go back to profiling. This next tip is a pretty simple one, but it's one that people forget about or miss often, especially when they're getting started out. And that's that we don't want to be getting components constantly. It's best if we cache them and do these slow operations once instead of a bunch of times. This doesn't only apply for getting components, but that's the easiest scenario to show and the most common one. So that's what I'm going to show you here. I've got my bird set up, and I've got this awake method that goes through and does some setup on the rigid body to control that bird that was flying around, and does some stuff for the line renderer to show the dots showing the angle that I was going to launch my bird at. And then if we look down here a little bit further, you'll see that we do some more work on the rigid body when we're resetting. And then when we hold down the mouse, we get our sprite renderer, change the color, and then we do some more stuff with the line renderer, again, continuing on and on and on in every one of these methods. All of these methods are constantly doing a search to get components on this object. Now that's not extremely slow. Get component is not a very, very slow call, but if I did this on something that was not just my single bird, maybe I did this on a character that I have 100 of, maybe it's on my monsters, and I'm constantly getting components, it's going to add up, and it's needless slowness that's just gonna hurt my game. So it's an easy thing to fix, and I'm going to show you how to fix it now. Also, if we were doing something other than get component, like a find object of type, and trying to do that every frame, it gets much, much worse and just kind of builds up. So let me show you how we cache these really quickly. The easiest way to do it is to take one of these little chunks where I'm getting a component, like get component rigid body 2D. I know that I want to cache all of my rigid bodies and just save them off. I normally do that in an awake. I'm already in an awake, so I'm not going to add a new one. But if I didn't have an awake method, say that this was start. In fact, I'll change it to start just to make the case. What I would do here is add an awake method, and then I would say underscore rigid body, if I'd spell it right though, equals, and then I would paste in the get component rigid body 2D. Then I'd hit home, hit alt enter, and generate a field for it. This will give me a private field for my rigid body that I can cache the rigid body reference on. Delete that private keyword and this private keyword just because they're unnecessary and I don't have them everywhere else. Get rid of that one too. And then what I would do is copy this rigid body. Well, first keep this on my clipboard, hit Control Shift F, no, not Control Shift F, Control F, and then hit the expand button right here. So if you're in Visual Studio, this is the find in the current file. Control Shift F is find in all files. Bad habit of mine. So hit Control F and hit this. And then what I want to do is paste down here on the bottom. What this does is make it so it goes from a find to a find and replace. So on the bottom, I'll paste in my get component of rigid body 2D. Oh no, I want to do that on the source. Paste that in as the source. And then for the bottom, I just want to replace that with underscore rigid body. There we go. And then what I can do is either replace next, or because I'm confident in it and I know I can undo, I can just hit find all or replace all. I hit OK. Notice that that does break this first one, so I need to change this back. Actually, I have that on my clipboard, so I'll just paste it in. And here I just continued along and did the same for the other two, so you didn't have to watch me do it, but went in and made a line renderer that's cached as well with the field up here and a sprite renderer, and then did the find and replace here. This will fix a lot of the issues. There was one other little thing in here though that experts might have caught. If we scroll down here, one thing people don't realize is that calling Camera.main actually finds the object of type with a tag. So if we're doing that in our mouse drag or in our update, we're also wasting performance. So we should probably cache this camera as well. To do that, I'll just take this Camera.main. I'm going to hit Shift Delete to put it on my clipboard and say underscore camera. Then I'll hit Control Home to go up to the top. And in my awake, I'll say underscore camera equals, and then I'll just paste in camera.main. This next tip applies to just about everybody. It's an issue that every Unity developer I've ever known has run into and had to fight with and then learn their way around. And that comes with spawning a bunch of objects and allocating a ton of garbage. Usually what happens is we spawn an object, we use it for a little while, and then we destroy it, and then we spawn an object, use it for a little while, and destroy it. And if we keep following this process, we can run into problems, especially if we're doing it rapidly. Here I've set up a simple example where I can spawn a bunch of objects with this particle clicker, and I just hold down the mouse and these little firework particles from the free cartoon effects pack appear. And you see them over on the left just filling up my hierarchy, and I'm going to stop and click on the profiler. If I go to any one of these frames here, you'll see that the GC alloc amount is 112 bytes. I'm allocating that much memory for every single one of these particles. These are very simple particles too. If it was a bigger prefab or object, it could definitely be quite a bit bigger. So how do I stop that? Well, first let's look at how it's done right now, how it's done wrong, and then we'll look at how to fix it into a simple pooling system for particles, and then we'll show it in action. All right, so we'll open up the particle clicker script, and here you see that we have a reference to a particle system using this particle prefab name and the serialized field attribute that was assigned to a cartoon effects prefab. Let's go look at that real quick. So here I've got my particle prefab, and it's assigned to the CFX2 spark hit. So I'm going to stop playing and go look at that because I did make a small change to it. So if I go select it and click on it, you'll see that it has an auto destruct script. I actually turned that off. The reason for it is primarily that it generates some garbage when it runs. It runs a coroutine which allocates. So even leaving it on with only deactivate still causes a little bit of garbage, and I don't want to clutter it up. So that's turned off, and that's what we're using to spawn the object. That's the particle that we're spawning. We get our mouse position right here on line 11, see where I clicked, and we're doing the nice slow non-cached camera.main call. And then we spawn the particle by calling instantiate of the prefab at the position using just the default rotation. Not much in here. So let's look at the cleaned up version. How do we speed this up so that we're not spawning a particle every frame? If we go into our particle system pooled and remove my breakpoint here, you see that it starts off very similar. We've got a particle prefab and then changes kind of right here. Update looks exactly the same, no difference. But we do have a field here on line 8 for a queue of particle systems. And a queue, if you're not familiar with it, is just like a queue in the real world or a line in the real world where things go in at the end and they come out at the beginning. So the longer something has been in the queue, the sooner it will come out. First in, first out is essentially what it is. So we've got this list of particle systems or queue of particle systems that's in order. And then when we spawn a particle at a position, instead of just instantiating it, we're doing something different. On line 20 here, let's just zoom it in a little bit. Zoom it out one, there we go. On line 20, first we look to see if there are no particle systems in the queue. If there's nothing in the queue, then we aren't going to be able to pull anything out of it and reuse it. So we're going to need to do the lines here on 22 to 24 to instantiate a new one, play the particle, and then in-queue it. The other thing that we do, so we check to see if there are none in there, but we also check to see if the top one or the next one ready is playing. If the next one ready is still playing, then hey, that one's not actually ready. It's just the next one in line. So we'll spawn another one and add that one to the queue. So this way, because my particle systems are all playing at the same amount of time, I can just reuse the last one or the oldest one and know that when that one's done playing, the one after that should be done playing too. And it just kind of keep going on. So assume that I didn't find one, we'll spawn one and we add it to this list. What if we do find one? Well, then we dequeue it using the dequeue, which is just the opposite of enqueue, which takes that first one from the line. We set it to active just in case anything turned it off. Then we need to do the important part of setting its position and telling it to play again. And then we'll add it back to the queue so that it'll be at the end of the line next time. So next time we want to spawn a particle, we'll keep knocking them down out of the line and let this guy move up. So that's all we really need to do this. Now, if you're not doing it with particle systems, you won't be able to check like is playing. Instead, you might want to check something like whether or not the object is active. But also, if your objects aren't deactivating and activating at the same time, what you might want to do instead is set up an event that fires off whenever the object is disabled that just re-adds it to the queue, or add some code into that object on disable so that when it disables, it just adds itself back into the queue. If you're curious about that, I've got a bunch of different pooling videos, and I'm going to do another one that's a lot deeper on different pooling techniques later. So just make sure you're subscribed or go look at the channel. You should be able to find the pooling videos. All right, I've got a lot more tips, but this video is already getting pretty long, so I'm going to wrap it up here. But if you're curious about just game programming or learning more about game programming, make sure that you're subscribed and that you just check out some of the other videos, or of course, check out my course. It's down below as well. And also, I wanted to say a special thanks to everybody who's already subscribed and already one of my students. I really appreciate you guys. You're all awesome. And definitely a special thanks to everybody on Patreon as well. All right, I hope this was helpful and you're able to apply it in your actual game projects. Thanks again for watching. Thanks for subscribing and hitting that thumbs up, and goodbye.